3-2, I believe. Yeah, lesson 3-2. We're going to talk about slope. And two components is we're just going to review the old strategy of how to figure out slope from a graph with rise over run and from a table in the change in x and the change in y. And then we're going to talk about the slope formula, which limits the amount of information I need in order to calculate slope. And so today's date is 12/14/15. Okay. So first thing is I need to introduce the letter that you will see slope is represented by in everything. And it's funny because I've looked at it, I've read different places. Nobody knows exactly why they use the letter that they use. So slope is represented by the variable m. And there's some gossip that, they said, well, they couldn't use s for slope because s is in the formula for perimeter of a square where it's 4 times s, and so they couldn't double dip on that variable. So somebody said, well, in French, the word for mountain is montagne. So m for mountain, because mountains are steep, and they have inclines and then declines, and that's what slope is all about. There is no validity to that, but bottom line, the letter m is whenever you see it, mathematically means slope, okay? And we just accept that. So let's talk briefly, how do we determine slope from a graph? So we'll put a little graph in here. I'm going to put some x and y, every other number. Now I'm only doing a small portion of the graph just for our purposes today, but there would be 2 points that would be highlighted in our graph. And we would figure out rise over run. And your option is, do I start from the bottom point and find where the upper point is, or do I go from the upper point down? And the choice is yours. So for me, we'd use this formula, rise over run. So now I can say m, well, let's do it underneath. Bless you. It's going to equal rise over run. So rise would be how far up, for me, because I told you guys before, I like to go from the bottom towards the top. So how much did I rise to get from my first point to get to the level of my second point? Oops, I went a little too far, didn't I? That's how far he is. Okay, how far did I rise?
2.
Okay, let's see, I rose from 1 to 3. Yep, so I had a rise of 2. And this is where it gets a little challenging when we're doing rise over run, is to make sure that we're counting spaces, not lines. And now I need to run till I hit the point. And how far did I run? How many spaces? 2. So I have a run of 2. And the direction I rose was up, that's positive. The direction I ran was right, and that's also positive. So that's how we get that. So we simplify that down, and we say the slope of this line is 1.
So
okay?
if you go left negative and go up again to positive, would it still be?
Well, if you go left, that's negative, but if you go up, that's positive. So then you would have a negative slope because you have one positive, one negative sign. If you went left and down, now you have double negatives. That would make it positive. Okay? And so that's what a lot of people like. For example, on this one, we could have gone down from the top point to the level of the bottom point and then left. So we would have gone down, negative, left, negative, and we still would have ended up with a positive 1, okay? So you just have to be cognizant of what direction you're moving. Make sure you get your signs in there. Plus, you look at that line and you go puff, puff, positive. Okay, so make sure that you remember about that. Okay, so let's look at it from a chart. Or table, let's call it a table. And basically, when we're doing it from a table, you guys did this when you were doing rate of change problems. That's all we're doing is a rate of change problem. So all that the table does is it lists multiple x's and y's. And in most of our tables, I think I've seen, what, 4 of them, probably, something like that. So here's my x is 0 when my y is 9. My x was 2 when my y was 4. My x was 4 when my y was negative 1. And then my x was 6 when my y was negative 6. So what I'm going to do is look for the change in x's and the change in y's. And then I have the change in y on top and the change in x on the bottom. So what do I do to get from 0 to 2? Excuse me.
2.
I add 2. We got to get the sign involved. How about 2 to 4? 2. I add 2. How about 4 to 6? I add 2. So what I had here is I had a constant change in my x value of 2. Every difference between my 2 points in the orders that they were listed, and they were listed from least to greatest, I had a difference of 2. And that delta means difference. We talked about that. All right, let's look on the other side. What did I do to get from 9 to 4?
Minus 5.
I subtracted 5. How about from 4 to negative 1?
Minus 5.
Subtracted 5. How about from negative 1 to negative 5? So what I had is every time I had a change in y of negative 5. So the change in y is the same as rise, and the change in x is the same as the run. So if I put those together, my slope is going to equal rise over run, or in this case, change in y over change in x. And again, I'll put the parentheses here. This is your rise over your run. Okay? And we just put the numbers in, and we get negative 5 over 2. Okay? And that would be the slope for this particular one, would be negative 5 halves. Okay? So what I want to share with you today is a formula that we can use to help us calculate slope. So, the slope formula. So instead of needing to have a chart of 4 pairs to look for a constant rate of change, all I need to have is 2 sets of coordinates. So 2 ordered pairs. So it requires 2 ordered pairs. And with those ordered pairs, you're going to calculate 2 things. You're going to calculate the change in y, and you're going to calculate the change in x. Okay? And then you're going to put them over as like rise over run. So we're going to write our final answer as that change in y over the change in x. Okay, so let me give you coordinates for the two ordered pairs. In order to come up with a formula, we use variables. So my x and y for my first ordered pair is going to be x sub 1, y sub 1. So the little low 1 just is saying these two belong together. So this is your first ordered pair. And then your second ordered pair would be x sub 2, y sub 2. And, oh, that doesn't look good. Let's try that again. And if you remember, change just means difference. The only thing we have to watch out for is how we subtract. So I'm going to give you the formula, and then I'm going to show you a way to help you keep things in order. Jacob, we're taking notes. So for this one, to figure out the change in y, I'm going to take my y coordinates and subtract them. That's how I figure out what the change is. For my x's, I'm going to do the same thing. But what I have to remember is I took the y from the first ordered pair in front, and I subtracted the y from the second ordered pair. I'm going to do the same thing with my x's. So I have x sub 1 minus x sub 2. They have to be, these have to come from the same ordered pair, and these, the second group, have to come from the same ordered pair. So he goes here, and he goes from here. Okay. So if we put it all together, we get y sub 1 minus y sub 2 over x sub 1 minus x sub 2.
That's confusing.
Oh, it's very simple. Super simple. So let me show you how to keep this straight in what you're going to be working on. So let me give you two ordered pairs. So find slope using only the ordered pairs, the two ordered pairs. So in other words, you can't draw a graph. We can't make a table of it because there's only two things in it. Okay, so we're just going to go ahead and try this formula. So our formula that we're going to use is slope equals, and I'm going to subtract my y's, and I'm going to divide it by the difference in my x's. Okay. So here's my two ordered pairs that we're going to use. One ordered pair is 1, 2. We'll call him R. And the second ordered pair, S. Now let's make this a different color. Let's make it bolder. S. And his coordinates are -4, 3. So in order to get your values in the same location, exactly where they need to be, what you're going to do is take an ordered pair, and you're going to do a rotation. Okay? So rotation says you're going to make a 90-degree turn. So that's going to put the 2 on top and the 1 on the bottom. That puts your y on top and your x on the bottom. So for ours, we're going to get slope equals our first point, 2 over 1. So that's my y on top, my x on the bottom, and they come from the same ordered pair. That's going to ensure just what I have that I circled up above, y sub 1 over x sub 1. Next, I'm going to take this ordered pair here, and I'm going to do a rotation, whoop, like this. So that's going to put the 3 on top, the -4 on the bottom. But notice what the formula says that I'm supposed to be doing. I'm supposed to be subtracting these y's, and I'm supposed to be subtracting the x's. So what I do is I connect up those two ordered pairs to make it one fraction, and I put subtraction signs in between them. So the numerator is really, Giselle, 2 take away 3. and my denominator is 1 take away negative 4. So what's 2 take away 3? So I get a negative 1 in the numerator. And what's 1 take away negative 4? Yeah, the two negatives make a positive, and I get 1 plus 4 is 5. And that's how I get my answer, okay? So let's do another one. And again, all I'm doing is taking my ordered pair as x, y, and rotating it so the y is on top and the x is on the bottom. That's all I'm doing. I'm just writing that ordered pair as a fraction with y's on top, x on the bottom. So let's do another one. So let's make our 2 points. Why don't you guys, somebody give me a point. Yell out coordinates of a point.
5.
Okay, 5's not coordinates, that's just one piece.
5 and 2.
5 and 2. Okay, and now I need a second ordered pair.
Negative 3 and 4.
Negative 3 and a 4. So to figure out slope, I'm going to take each ordered pair and I'm going to turn them into a ratio. Y on top, x on the bottom. Second order pair, y on top, x on the bottom. Connect them, subtract them. What's 2 take away 4?
2.
Careful. Negative 2. And what's 5 take away negative 3? Yeah, 2 negatives make a positive and we get an 8. Oh, it needs to get simplified exactly. So we notice that they both have a 2 in common, so we divide out the 2 and we get negative 1 over 4. So my question is, what if I put the green fraction in front, the second order pair in front, and the first order pair in the back? Is that going to change my answer?
No.
So let's prove it out. So again, I take my ordered pair, the green one this time, and I'm going to put the y on top and the x on the bottom. I'm going to take my first ordered pair, my blue one. I'm going to put my y on the top, x on the bottom. Then I'm going to connect them and subtract them. Okay, what's 4 take away 2?
It does. 2.
2. And what's negative 3 take away 5?
Negative 8
So I can simplify
equals
by 2,
negative.
and I still get negative 1 over 4. What only changed is where the negative ended up originally in the problem, but when I write my answer, I write the negative usually in the same location, always in the numerator. And so it doesn't change. That's what's beautiful about this formula, is that it doesn't matter which order pair I put in front and which one I subtract from it. It doesn't matter. As long as I remember that I have each fraction represents one set of ordered pairs. Okay? All right.